Hello, in this video I will go over some basic matrix operations such as adding, subtracting, multiplying, transpose, and finding the determinant of a matrix. So let's start with the basics. Adding and subtracting matrices. So did you know that um, in order for matrix to be to add or subtract, matrix must be the same size, dimensions. Um, so yeah. If one matrix is a 3 by 3, the other matrix has to be a 3 by 3 as well. Right? So yeah, if matrix A is 3 by 2, matrix B must be 3 by 2 in order to add or subtract. If it was a 3 by 3 and then this was a 3 by 2, you cannot add or subtract these two matrices. Okay, what about scalar multiplication? That's pretty simple. You just literally multiply whatever that scalar is for to each number on the entries. For example, let's say you had to multiply the scalar 3 by this matrix 1, 5, 2, 3. All you're doing is multiplying each term by 3. So this would be 3, this would be 15, this would be 6, and this would be 9. You're not changing the size or the shape. It's just you're just multiplying each number by 3. What about a transpose? So we'll talk about that more. Transpose basically switch the rows and columns. It is denoted by a raised to the t. Okay. What about the term trace? You might hear the word trace in your linear algebra class. So basically, it's a sum of the diagonal entries in a square matrix denoted by TR and then parentheses A. And this is also very important. It can only happen in a square matrix. A square matrix is equal to equal rows and columns. Diagonal matrix. Basically, it's what is a diagonal matrix? It's basically a square matrix whose non-diagonal entries are 0. So whose non-diagonal entries are 0. So this is an example of a diagonal matrix. If you go, these numbers are non-zero, 1, 3, 4, there are non-zeros, and then the rest are zeros. So that's how you know you have a diagonal matrix. What about multiplying matrices? So it's a little bit different from adding subtractions. They don't have to be the same, but these two numbers has to be the same. And then your final matrix will be measured by this two numbers. So an example, 1 by 3 by 3 by 5. So let's call this matrix A and then let's call this matrix B. Can these two matrices be multiplied? Yes, because these two numbers are the same. And then your final matrix will be these two numbers, 1 by 5. Okay. Yeah, that's very important when multiplying matrices. You cannot divide matrix to matrix together. Instead, we use what's called inverse. So let's kind of talk about the entries of a matrix. So if you look at this first term A, and then you have this little subscript 1, 1, what does this 1, 1 mean? So this 1 means row, and then this other one means column. So it's very helpful when uh, finding that specific number. So yeah, this one, like if you want to describe this number, you can describe it as um, the second row or the ith row. by the jth column, right? So whatever this number is, you can describe it by saying it's located on the ith row by the j column, or you call it the second row, second column. Uh, diagonal entries are A1, A11, A22, A33, and AMN. So let's see if that's true. A11, A22. Oops. Yes, that sounds about right because here's A11, here's this could be A22, and then the third one would be A33. Yeah, so this would be your diagonal matrix. I mean diagonal entries, not matrix. Uh, let's okay. So now you know how when you can multiply, when you can add and subtract, you cannot divide two matrices and instead you find inverse. You can locate a number on the matrix. Those are very going to be very helpful when we do some problems, some operations. Okay, let's talk about matrix properties. So matrix properties let A, B, and C be matrices of the same size, and let A, B, and C let A, B, and C be matrices of the same size, and let R and S be scalars constraints. So these are just some properties. Um, did you know that you can switch these around? A plus B is the same thing as B plus A. Yeah, if you have matrix A and you have matrix B, you can also call it matrix B plus A. Uh, if you have A plus B, parentheses A plus B plus C, that can also be expressed as A plus parentheses B plus C. And if you have A plus 0, that's just going to give you your A matrix. It's also called the zero matrix. Now, this is something very important. Rule 4, you have R times A plus B. So you're multiplying or foiling out this R. So this is RA times RB. Now notice that it's on the left side, right? It's also important. That means this number will also be on the left side. Now compare that with rule 5. Let's say you have parentheses R plus S times A, and you want to FOIL it out. Notice that the A is on the right side. So that means your A will be on the right side. So when you FOIL this out, when you FOIL out this A, this is also be expressed as RA plus SA. So yes, order is very important. 6, we have R times SA. That can also be expressed as parentheses RS parentheses A. Yeah, because look, where is R? R is on the left side. So the R must also be on the left side on the other side, right? And then 7, if you have A times B times C, the A is still on the left side, so the A must be on the left side as well. 8, let's say you have A times B plus C. A is on the left side. So when you FOIL this out, this is A times B times AC. Rule 9, if you have parentheses B plus C times by A, notice that the A is on the right side. So it would be expressed as BA plus CA. Okay, number 10. You have I subscript M times A. That's equal to A equals A times I subscript N, and that is called an identity matrix. Okay, so one more very important rule, another important rule. When you're multiplying matrix, for example, if you're multiplying matrix A times B, it does not equal matrix B times A. Okay, you cannot switch these orders. You'll see. Um, when you're multiplying when you're multiplying A times B, it's not the same thing as a matrix B times A. So order is very important. Okay, let's do some examples because now we know some rules, properties. Let's do some rules. So perform the matrix operations. Given that here's matrix A, it looks like it's a 2 by 3. So it's matrix A 2, 0, negative 1, 4, negative 5, 2. Matrix B looks like it's also a 2 by 3. Matrix C is a 2 by 2, and matrix D is a 3 by 2, right? And we want to do there's like several parts for this one. It's negative 2 times the matrix A. So negative 2 is a scalar. So you can rewrite this as negative 2 and then times A. This A is 2, 0, negative 1, 4, negative 5, and 2. So when you FOIL out this negative 2, this is going to be negative 4, negative 2 times 0 is 0, negative 2 times negative 1 is positive 2, negative 2 times 4 is negative 8, negative 2 times negative 5 is positive 10, negative 2 times 2 is negative 4. Okay, so negative 2A is going to equal to this matrix. As you can see, it doesn't change the order, it just changes the scalar. Okay, matrix number 2 says we have to find matrix B plus matrix A. So first off, we got to check if we can add these, because so matrix B is a 2 by 3. Matrix A is also a 2 by 3. So can we add them? Yes. So if you recall, matrix B is 7, 1, plus matrix A is also 2 by 3. It's 2, 0, negative 1, 4, negative 5, 2. So when you add these two matrices, it's going to be expressed as 9, negative 5, 0, 5, negative 9, negative 1. So that is matrix B plus A. What about trace, TRC? So can we take, what is TRC trace? What does that stand for? It stands for. It's basically the sum of the diagonal entries in a square matrix. So whenever you see, yeah, it's basically the sum of the diagonal matrix of a square matrix. So it can only happen in a square matrix. Uh, So is matrix C a square matrix? I think so, right? So matrix C is this. 1, 3, 2, 4. It's definitely a square matrix. It's a 2 by 2 matrix, right? 2 rows, 2 columns. So we definitely can do this. So all you got to do is add the diagonal. So TRC is basically adding up the diagonal. So it's 1 plus 4, which is 5. Okay, number 4. What about D and the transpose? So vector D, what was vector D? I mean, not vector, matrix D. It was a 3 by 2, right? It was 1, 0, -2, 2, 1, 4. So D transpose is this. So basically, this is what was this? A 2 by 3. So you just switch the order. You switch the rows and the columns. So now it's going to be a 3 by 2. So if you can visually see this, what you're doing is taking this row and turning it into a column. And the same thing with this. You're taking this row and making it into a column, taking this row and turning it into a column. And somehow it's going to be a 3 by 2 matrix. So it's going to be, so take this row and turn it into a vertical column. So it'd be 1, 2. Take this row and turn it into a vertical column. It would be 0, 1. Take this row, turn it into a vertical column. It would be -2, 4. So this would be the transpose of D. What about 5? Can we take the trace of matrix A? Uh, I don't think so because A is a 2 by 3 matrix, so it's not a square matrix. So there would be no solution. And A does not equal a square matrix. No main diagonals. So, okay. So you can't take the trace of matrix A because it's not a square matrix. What about the matrix B and can you take the transpose of it? I think so. So matrix B was technically a 2 by 3. So your new matrix, your B transpose will now be a 3 by 2. What is matrix B? Is so B transpose. All you got to do is imagine this row turning into a vertical column. So it'd be 7, -5, 1. Imagine this row and turning it into a vertical column. It would be 1, -4, and -3. Okay, 7. Uh, we're multiplying 1/2 by the vector d, so 1/2 is technically a scalar. So it's basically saying 1/2, and then your matrix is 1, 2, 0, 1, -2, and 4. When you multiply this by 1/2, 1 times 1/2 is 1/2. 1/2 times 2 is 1. 1/2 times 0 is 0. 1/2 times 1 is 1/2. 1/2 times -2 is -1. 1/2 times 4 is 2. There you go. Question 8. So question 8 says multiply matrix A by matrix C. So first, they got to be the same. So matrix A is, I mean, not the same. They have to be, so matrix A is 2 by 3, and matrix B is a 2 by 2. So can you multiply these two matrices out? No, because these have to be the same. So yeah, no solution. Okay, good. Okay, let's practice more on multiplying matrices. So let's do this example. Let's say you have the matrix A, which is what? Matrix A is a 2 by 3. And then let's say you have matrix B, which is a 3 by 2. Can you multiply these out? So you have a 2 by 3 by 3 by 2, right? Can you multiply these two matrices out? Yes, because these two numbers are the same, and then your final outcome will be a square matrix 2 by 2. So how do you do these ones? So it's going to be a 2 by 2 matrix, and basically we got to find a number here. Number, this will be a number, and this will be a number, this will be a number, and this will be a number, right? So what you're doing is you're define. Let's start with this number. What would this number be? It's basically this row by this column, right? So you can express it as R1, C1. And then this number here could be expressed as R1, C2. And then this number here could be expressed as R2, C1. And then this number could be expressed as R2 times column 2. So yeah, let's do this number right here. So is R1 times column 1. So this row 1 times column 1. So that could be expressed as, so so it's going to be 2 times 1 plus 0 times 3, and then -1 times -2. And when you put that together, you get 4. Now do the same thing here. Now it's going to be row 1 times column 2. So it's this row times this column. So it's going to be 2 times -6 plus 0 times 5 plus -1 times -4. And when you do that, that gives you -8. Keep on going. So this one will be row 2 times column 1. So here's row 2 times column 1. So that would be 4 times 1 plus -5 times 3 plus -3 times -2. And when I do all that work, it should give me -5. And then do the same thing here, this row times this column. So that is going to be 4 times -6 plus -5 times 5 plus -3 times -4. When you do all that work, it should give you -37. Okay, so that is how you multiply two matrices. Okay, let's do more practice. So, example, multiply the given matrix. Matrix A is 2 by 2, which is that, and then matrix B is that, is also 2 by 2. So always check if we can multiply these two matrices. So yes, because this is a 2 by 2, this matrix B is also 2 by 2. These two numbers are the same. Your final output is 2 by 2. Okay, so how do we do this? Matrix A is 2, 4, 1, 0. Matrix B is 1, 3, 5, and -2. So it's going to be a 2 by 2. And what number will this be? So it's basically this number times this row. So it's row 1 times column 1. And then this number here will be row 1, column 2. And then this number here will be row 1, column 1. And then this number times this one is row 2, column 2. So when you put it all together, this is what you'll get. So let's start with this number here, row 1 times column 1. So this row times this column. So how do we do that? It's 2 times 1 plus -1 times 3. Now let's do this number here. It's basically this row, first row times this, now this column. So that is going to be 2 times 5 plus 2 times 5 plus -1 times -2. And then this one right here, it's this times this. So it's 4 times 1 plus 0 times 3. And then this one right here is going to be 4 times 5. Right? Yeah, 4 times 5 plus, so this row and then this second column, 0 times -2. Okay, so when you put this together, 2 times 1 time plus -1 times 3, that's -1. 2 times 5 plus -1 times -2 is 10 plus 2, that's 12. 4 times 1 plus 0 times 3 is 4. 4 times 5 plus 0 times -2 is 20. Okay. Now I'm going to show to you that, remember we went over a rule that says AB does not equal to B times A. So that's, I'm going to prove that. So the next problem or the next question says 10B, find B times A. Okay, so order does matter. So matrix B is 1, 3, 5, -2. Matrix A is 2, 4, -1, and 0. When you multiply this out, it's going to be this row by this column. This is row 1 times the first column. And then the second one would be first row, second column 2. And then this row would be row 2, column 1. And then the same thing here, it'd be row 2, column 2. So let's do this. So this times this, so that's going to be 1 times 2 plus 5. Wait, so 1 times 2 times 5 times 4. And then this number here is this row by this column. So that would be 1 times -1 plus 5 times 0. And then over here, it's this row by this column. So that's going to be 3 times 2 plus -2 times 4. And then this row by this column. So that would be 3 times -1 plus -2 times 0. So, yeah, when you get your final answer, you're going to get this 22, -1, -2, -3. See, as you can see, this is not the same thing as AB, because AB was it was -1, -1, 4, 12, and 20. Okay, let's talk about powers of a matrix. So powers of a matrix. So you have A raised to the K. A raised to the K equals A times A. So A to the K is the same thing as A times A times A. You cannot distribute an exponent unless it's a diagonal matrix. So, for example, here you have and this is not a diagonal matrix, because these numbers this 3 has to be a 0, right? So, yeah, you cannot just raise everything, but you can't raise everything to the third power. So 1 to the third, 0 to the third, you can't do that. But this is a diagonal matrix. Why is this a diagonal matrix? Because these numbers are numbers, and then these are zeros. So when you do that, when you can raise it each term by 3. So yeah, unfortunately, for example, this one is not a square matrix, so you just got to multiply it out. So this matrix 2 by 2, 1, 3, 0, 2, is basically multiplying itself 3 times. So what I would do is multiply these two out, and whatever that matrix is multiplied by this matrix, by the third matrix. Okay, so when you multiply it out, you get this matrix. I kind of did it for you. So, so yeah, multiply out these two matrices, and you get 1904, and then multiply this by 1302. Okay, let's talk about determinants. So determinants basically is a number that is assigned to a square array of numbers in a certain way. They are special numbers. They are special numbers that help us solve bigger problems. They can only be found for a four-square matrix and are denoted as this determinant of A or the absolute value of A. So we're going to talk about how do you find, so your final answer will be just a number, and we're going to talk about how to find it when a matrix is 2 by 2 and a 3 by 3. 2 by 2s are pretty easy. Yeah, so at 3 by 3s, it's a little bit more work. So with the 3 by 3 or larger, expand the minor's cofactors. So I'll explain what that means. So let's say you had a 2 by 2 matrix and you want to find the determinant. So what you have to do is it's the major minus the minor. So basically, what do I mean by major? It's this diagonal. So you multiply these two numbers, AD, minus the minor, which is the multiplication of these two numbers, right? So let's say you had a 3 by 3 or larger, expand by minors. Okay, so now what about the 3 by 3? So what you have to do is like you look at the okay, so this number here is A is going to have a positive coefficient. This number here, B, will have a negative coefficient. This number here will be a positive, and then this would be a negative. This would be a positive, negative, positive, negative, and a positive. So what you do is whatever this number is, and it's gonna be a positive coefficient. What you're gonna do is visually you're gonna remove the row and the column that has this letter A. So imagine getting rid of this row. So put a straight line here and then get rid of this column right here. And now you're left with this numbers E, F, H, I. Okay. And then it's going to be a negative B. So whatever this coefficient is, doesn't matter if it's a positive or negative, you're going to put an extra minus if you need to. And then just like that, the other one, you're going to ignore the row, and then you're going to ignore the column. So you're left with D, F, G, I. Okay. And then the third one, whatever this number is, it's going to be positive, and then you're going to ignore the row that has C, and then you're going to row the column that has C, so you're left with D, E, G, H. And then you would take the determinant of a 2 by 2, which is easy. Okay, so now that you know, let's go over some skills. Calculate the determinant for each matrix. So matrix A, you have 6, it's a 2 by 2, it's 6, 3, 1, 10. You want to find the determinant. So basically you multiply 6 by 10, 6 times 10 minus 1 times 3. So that's 16 minus 3, which is 57. Right? That's not too bad. 2 by 2s are not too bad. Oops. Okay, what about matrix B? We have a 2 by 2 matrix, a square matrix, and we have 4, -6, -2, and 3. So what you're going to do is, it's a 2 by 2, so you're going to multiply the major. So 4 times 3 is 12. Minus, so be careful with the minus. Make sure you always put a minus, and then if your number also has an extra minus, put a minus as well. Minus -6 times -2 is positive 12, and then 12 minus 12 is 0. Okay. Okay, so this one says calculate the determinant of each matrix. Okay, this one is a 3 by 3, and this is a little bit more work. Okay, so how do we do this one? So let's talk about the cofactors. This is going to be a positive, this is going to be a minus, and then this is going to be a plus. So let's start with the cofactor 2. Take that out. And then visually, like if you have to put like your fingers, eliminate the row and eliminate the column. So eliminate this row and then this column. And now you're left with 10, 0, -5, and -1. Okay, and then this, now let's look at this -2. So be careful. So this is going to be a minus, and then whatever this cofactor is, so that you have an extra -2 here. And that, yes, that will become a positive. So visually, if you need to use a pencil, ignore all the rows and all the columns with this -2. So this, ignore this, ignore this. And what are you left with? You're left with 7, -5, 1, and -1. Now do the last term. This is going to be a positive, but we also have a -3, so it's going to be a -3. And then ignore the rows and ignore the columns that has the same 3. So you're left with 7, 10, 1, 0. Okay. Okay, now what do we do next? So we're going to clean this up. So now we have 2 by 2 matrix, which is easy. So this is going to be 2. And then how do you find the matrix of this? It's major minus minor. So 10, it's basically saying 10 times -1 minus 0 times -5. And then over here, 2 negatives becomes a positive. And then it's going to be 7 times -1 minus 1 times -5. Over here, plus or minus, so that's -3. And then 7 times 0 is 7 times 0 minus 1 times 10. Clean this up. 10 times -1 is -10. -0 times -5 is 0, so that's -10. Plus 2. 7 times -1 is -7. -5 times 1 is -5, but be careful, you also have this minus, so it's negative at -5. And then this is going to be -3. 7 times 0 is 0. -1 times 10 is -10. And this up, 2 times -10 is -20. Over here, 2 negatives becomes a positive. So -7 plus 5 is -2. And then this is plus -3. And then 0 minus -10 is -10. Clean this up. So this is -20 plus 2 times -2 is -4. -3 times -10 is positive 30. And when you put it all together, you get 6. So I think this is also later on, I think this is called Cramer's rule as well. So if you have done Cramer's rule, I think it's the same process. So let me recap what it did. So if you have a 3 by 3 matrix, you take out the cofactors. Uh, the this number, this cofactor will always be positive. This cofactor will be a minus, and then this cofactor will be a plus. Doesn't mean that number will be a plus minus plus, right? Sometimes you might have an extra minus because this number might be -2. But you take out the cofactor. So if I took out 2, and then what you do is like visually ignore the rows and columns that has this +2. And then you're left with this matrix. And then the second cofactor will be a minus, so I put a minus here, but this also has a -2, so you're gonna put a -2. And then ignore the row and the column by that -2, and you're left with this. Now do the third one. This number here will have a positive cofactor, but be careful, there's a -3. So ignore the rows and the column with that -3, so you're left with 7, 1, 10, 0. Now you have a 2 by 2 matrix, and it's easy to find the 2 by 2 matrix. So if you look at this, it's going to be 2 and then multiply 10 times -1 minus 0 times -5. And then over here, 2 negatives becomes a positive. And then you're left with 7 times -1 minus 1 times -5. Over here, you have a -3, and then it's 7 times 0 minus 1 times 10. Keep on going, and then you get 6. Okay, so now you know how to take a determinant by a 2 by 2 and a 3 by 3. Let's wrap this video up with some review theorem. So let A and B denote matrix whose size are appropriate for the following sums and products. So if you have A transpose raised to the T, or raised to the, yeah, AT raised to the T, these cancels and you're just left with just A. Well, let's say you had parentheses A plus B raised to the transpose. So you just have to raise everything to the transpose. So that's the same thing as A to the transpose plus B to the transpose. And then C, you have RA raised to the T. That's the same thing as RA raised to the T for any scalar. And then D, you have A times B raised to the T. That's the same thing as A times B raised to the T is the same thing as B raised to the T times A to the T. The transpose of a product of a matrix equals the product of their transpose in reverse order. So let me read that again. The transpose of a product of a matrix equals the product of their transpose in reverse order. And also remember, matrix A times matrix B does not equal to matrix B times matrix A. Okay, we just proved that before. Okay, so yeah, this is basically an introduction of matrices and properties and operations. We're going to go more in depth. Yeah, we're going to go more in depth in the next videos. I'm going to stop here.